Alright, how's it going, y'all? Today we've actually got a fun one, and we're going to be turning a Raspberry Pi into a Wi-Fi router. And this is actually going to allow us to do a few different cool things, and one of them is it's great for a road trip or something like that, where maybe you have one single hotspot that you want multiple people to be able to connect to, or even you just want a super simple portable NAS, and that's kind of what I'm going to be doing here. This will allow you, no matter where you are, to be able to connect your Raspberry Pi over Wi-Fi and be able to access all the files off of it. This will even allow multiple people to all connect to it over Wi-Fi, and that means you can have a network file share for multiple devices in the middle of nowhere. This is a really great setup and even use 5 gigahertz. And the reason we're able to do this is honestly the fact that a Wi-Fi receiver and a Wi-Fi transmitter are basically the exact same thing. Normal Wi-Fi routers do have more capacity for more simultaneous connections, but in all honesty, the principles are exactly the same. You have devices connect, and as long as there's an operating system controlling it, such as Raspbian here, we're going to be able to do this all incredibly easily, and it's going to give us a lot of options here. And so at the end of this tutorial, what you're going to be able to do is plug any Ethernet cable into your Raspberry Pi, and it will be broadcasting a Wi-Fi transmission. And it will act just like your router. You'll have your own Wi-Fi network created, and honestly, the Ethernet cable is optional. Instead, if you want to be able to access everything locally, you don't need an Ethernet cable. All you need is a Raspberry Pi, a power supply, and some kind of storage. I'm going to be using an external SSD for this because they're really fast, but you could honestly, if your files are small enough, just use the micro SD card in there. Alright, and so now without further ado, let's go ahead and get started. So the first thing we're going to go ahead and do is SSH into our Raspberry Pi. And as you can see right here, I've done a headless setup. And so currently, Wi-Fi is blocked by RF kill. So the first thing we're going to want to go ahead and do is change that. So we're going to do a sudo raspi. And this is actually because different countries have different laws on what can use Wi-Fi at what frequencies. And so to be compliant and to be sold globally, the Raspberry Pi actually has to get you to enter your geographic location before it will allow you to use Wi-Fi. And that way it doesn't start broadcasting on an illegal transmission, and in the US they would get fined by the FCC. And so to do this, we're going to go into System Options, Wireless LAN, and see, we're going to have to select our country, and I mean the United States. Just going to call it a space and space, and it's going to fail to set the SSD or password, but that is okay because now we're going to go ahead and reboot. And so what we did there is we entered the country, but we didn't enter a password or anything. And so that meant it failed to connect to the Wi-Fi network. But when we boot up, we're not going to have this message, which means we'll be allowed to use Wi-Fi. And so we just logged in. And as you can see, we no longer have that, hey, your Wi-Fi is blocked. Because now it knows where we are and therefore knows what frequencies it can transmit at. So now we're going to have to install some software first. So we're going to do a sudo apt update to update our package links. And now we're going to install a few packages. We're going to do sudo apt install host ap, host apd, whoops, typo there. Basically what this does is it actually allows our Raspberry Pi's Wi-Fi antenna to actually become a host instead of a client. And we're also going to install Dns Mask. This is to allow services such as DNS and DHCP, which is the job of a router, to occur on our Raspberry Pi. If you were going to do everything statically, you actually would not need to do this, but you would need to set up every single one of your clients to have a static IP address assigned within the subnet. But we want our router to be able to give everybody IP addresses, so we're going to install DNS Mask. That's mask with a Q. And so now we're actually going to do one more, and it's a weird command, so I'm just going to paste it in here, and I'll put this in the comments. And so basically what we're doing here is we're running a Debian front-end package. Raspbian is based off of Debian, but it is a different installation process. And what this is going to do is our Raspberry Pi to start acting more like a router. It's going to have iptables-persistent, which means every time you reboot, they're going to start back up. And it's also going to have a net filter that starts blocking things outside of your network. And so we're just going to click enter on that, and I'll go ahead and leave that command in the description below. Alright, and so now that's done, I'll go ahead and clear it to give us some space. And now we need to set up our access point. So first off, we're going to set it up to start up on boot with a sudo system control, unmask, host apd.service. All right, so we just removed it, and now what we need to do is enable it. All right, and so now we actually need to set up the router part of this. There is a difference between an access point and a router. A router doesn't even have to have wireless capabilities. A router is just in charge of basically taking the internet or a larger network and routing it into a subnet. This is things like port forwarding and firewall rules, and DNS entries and DHCP entries. Basically, it's in charge of giving everybody IP addresses and telling everybody where to go. And when you want to go to Google, it basically says, okay, you want to figure out where Google is? Talk to this guy. And when you first connect, it goes, hey, you're connecting to my Wi-Fi router. This is your IP address, and it assigns it. That way there's no conflicts. And so that's what we're going to be setting up first. And so to do that, we're going to edit the DHCP configs first. So we're going to do a sudo nano, which is our text editor, and it's an etc dhcpcd.config. And so these are already things that have been pre-configured, and we don't want to mess with those. But what we're going to go down to is we're going to go down to the very end. And so now we're going to configure our wireless LAN to become an access point and have its own IP addresses. And so the first thing we need to do is create that and choose our subnet. So subnets are basically networks within networks. So for example, most of the time you think of a local IP address as 192.168.1.something. That's what most people's routers out of the box set up. There are 3 domains that are open for local subnets or private domains. There's 10.anything, then there's 192.168.anything, there's 172.something, I can't quite remember that one. And so you just need to make sure that this is going to be different than any other networks you connect to. And so you don't want to have an issue where you're getting an IP address that is assigned already to somebody else. And so what I would recommend doing is setting this up on the 10.20 domain. Nobody's going to be using that most likely unless there's a very special configuration, which you're probably already going to know about. And so we're going to say interface and WLAN 0. You would also set this up the other way around where you got Wi-Fi from somebody and had everybody connecting locally as well. And so instead of saying WLAN 0, you would say ETH0 to say that your Ethernet is the route that everybody's going to be taking. But we're going to say WLAN 0 for our Wi-Fi connection. And we're going to say static IP address. And we're going to say what subnet we would like everybody to connect to. And so I said we're going to do this on the 10.20 domain, right? So 10.20.1.1/24. And so our router is actually going to get the first entry here, which is the 10.20.1.1. And so it gets that one, and that's really common, is it for it to either be number 1 or 0. I would really recommend number 1. And we're also going to enter no hook, WPA_supplicant. And so now we're all going to be set up. So now we're just going to do Control X to exit, Y to write it, Enter to save it. All right, and so now what we just did there is we said whenever we're on WAN 0, which is our wireless network, we get the IP address 10.20.1.1 with the subnet mask 24. And so now what we need to do is create a router. So we need to have connections that are on the Ethernet cable, be able to go through the Wi-Fi chip. And so that's where the routing comes in. And so to do that, we're going to edit the AP control with sudo nano /etc system control. And so now all we need to put in this file is net.ipv4.ip_forward equals 1. And this is going to say we're going to be forwarding IP4 addresses. And now just save it. And so now we've just created this file. All right, so now we've just set it up. So now traffic is allowed to go from the Ethernet port to the wireless port. What we need to do is tell it where to go. So to do that, we're going to do IP tables. So that's sudo iptables -t nat -a post routing -o for origin, which is ETH0. So if you were to be doing this the other way around where you have a Wi-Fi network and then you want routing on the Ethernet cable, you would do WAN 0. But if you're setting this up as a Wi-Fi router, you're going to do ETH0 for the origin, -j, and masquerade. All right, and so now we just need to save that with a sudo netfilter persist, and save. All right, and so now what we're actually going to do is we're going to set up DHCP services on our router over our access point. And so what we're going to do is we're actually just going to delete the old config file and just start anew because it's a lot simpler to go from that. And so what we're going to do is we're just going to do a sudo rm for remove, be careful here, and it's etc/dns mask.config. And so we're just going to delete it. What you could also do, and it's probably best practice, is we'll just move it actually. So it's a move, but it's actually just going to be a rename, and we're going to rename it to. So basically what we're doing here is we're moving this file to the exact same place, just with a new name. And so what we're doing right now is it's a rename, but to Linux, it's a move. And so now we can just start anew with a sudo touch etc dns mask.config. And so now we just create a file. You also don't have to, you can just do it from nano and it'll automatically create the new file, but it's good practice. And so now what we're going to do is a sudo nano to edit it. This is going to be a blank file. And so now we're actually going to start setting this up as a true router. And so to do that, we're going to enter only 4 lines. We're going to first specify the interface for WLAN 0. Once again, if you want to set this up where you got Wi-Fi in and then route everything through Ethernet, you would specify the interface being ETH0. And so now we're going to specify the DHCP range. And so DHCP range is basically what IP addresses will be handed out. And so what they need to be is they need to be on the subnet that we created earlier. And so what we did for that was 10.20.1. And now where it starts. I'll go ahead and just start at 5 because I want to have 2, 3, and 4 as freebies for if I need to set up something up statically. And so this is where you start, comma, where you end. And we'll say 100. Basically, this router will give out IP addresses between 10.20.1.5 and 10.20.1.100. And now we just need to give it the subnet mask, which is 255.255.255.0, which is equivalent to the \24 that we set up earlier. So basically, anywhere you see a 255 means it doesn't vary. So the first 3 are 255s. So this one, and this one can't change. But the 0 means it can change. So these IP addresses can change. That's a really basic explanation of DNS masks, but it's basically it. And now just how long DHCP reservations last for. And so we'll do 72 hours, why not? And so basically this means this is how long somebody has a DNS address for before it goes back into the tables. And so since we've got 95 of them here, we could do 72 hours, we could do 3 months. It doesn't really matter, especially if you're not connecting with that many people. It can be actually really nice to have everybody get the same IP address every time. So maybe we'll actually do 300 days. That way, if you're connecting with people all the time and you're doing something over LAN and you want to do that kind of stuff, you don't have to set up static IP addresses. Honestly, you can just have them connect every 300 days. It's up to you. And this file will also allow you to do a DHCP reservation for a specific MAC address, but that's a pain in the butt over command line, so I'm just going to leave it to you to Google that. It's not too hard though. And now we say what the domain is, and that's going to be WLAN. And so basically, this is the DNS domain that you're going to be using. So you could specify things as a custom domain to be spacerex.wlan and actually use a DNS server to resolve that. That's going to be out of the scope of this, but you do need to have one in there. And so now we're going to use that information to actually create a local domain name for this Raspberry Pi. And so what we're going to do is we're going to say address equals / rt4router.wlan. And we'll also say that's equivalent to 10.20.1.1, which is that IP address we set up originally for the router. And so basically whenever it sees rt.wlan, it'll say, oh, that's this. And so you could actually do that for additional things. If you wanted to set up, hey, I want to be able to type spacerex.wlan and get here, you would just add in another entry here. And this is all you had to do. And so we're just going to do Control X to exit, Y to save it, Enter to write it. All right, and so now we've basically done all the routing stuff. Now we just need to make our access point. And so to do that, we're going to create a config file in the host directory. So we're going to do a sudo touch to make the file, etc/host access point, apd, and we'll call it host apd.config. And so this is just going to create the file, and now we can use nano to edit it. Once again, you could just do the second command nano, but it's just good to create the file beforehand. It's good practice, I think. And so now I'm not going to type out all these configs. Instead, I'm just going to paste it in from the Raspberry Pi recommended config that Raspberry Pi has released. I'll link this in the description below. And so we're just going to paste it in there. And we're going to have to change a few things. First off, country code. I live in the US, and so I'm going to type US instead of Great Britain. You do need to make sure that this is the same thing we set up earlier, and it should be compliant. You don't want to be broadcasting on the wrong network and get arrested. It's very unlikely, but they do treat it very seriously, especially when it comes to radar. And if you're near an airport, you could actually get into some significant trouble because they will try to track those illegal transmissions down, because having unnecessary frequencies on there essentially jams radars at a very low point, but it does decrease their ability to track things, especially with air traffic control. It can be very bad. And so now we also need to change the network. We'll call it SpaceRex. And so now for the hardware mode, you get to select what frequency you want to work at. If you choose A, it'll be a 5 gigahertz network, which I would really recommend for short but fast transmissions. If you need something to go further, you should use 2.4 gigahertz. To do A, you do have to have a Raspberry Pi that's compliant with 5 gigahertz, which is basically the Raspberry Pi 3 Plus onward. And so now for channel, you could go through and figure out which channel had the least amount of traffic with you, but we're just gonna pick 7. It's probably fine. And down here are your encryption to get into the password. And so this is gonna be our passphrase. I like the default password, but we'll just say SpaceRex. Exclamation point. Makes it more secure, right? But I would recommend having at least somewhat of a secure password, because you don't want people being able to brute force their way into this too easily. All right, and so now we're going to be creating a Wi-Fi network called SpaceRex with a password SpaceRex exclamation point. You should be more secure than that, but that's all you need. And so one thing I did forget to do was when we changed the hardware mode to be 5 gigahertz, we actually needed to change what channel it operates at, because 7 is not available on the 5 gigahertz network as it's a 2.4 gigahertz network. So we're going to do channel 36. And so now we're going to go ahead and save that real quick and do a reboot. And that would be why I was having issues. And so now we've rebooted it, and if we go up here, we can see under Wi-Fi channels, SpaceRex is an option. And so it's going to ask for our password, and so we're going to say SpaceRex exclamation point. And so now it's going through and connecting, and we are good to go. And so now to kind of explain what we've done, I'm going to go ahead and open up my network preferences. So currently I'm in a hardwired Ethernet connection. And as you can see right here, I'm also connected over Wi-Fi to this subnet 10.20.1. And so that means we've successfully connected back. And so we should be able to go ahead and ping 10.20.1.1, which is our Raspberry Pi. So I'm going to do ping 10.20.1.1. And just like that, it is working. And more importantly, it is working over Wi-Fi, because that 10.20.1.1 is the IP address of the router, which is our Raspberry Pi. And so now we can also do something extra here. I set up this Raspberry Pi as a Samba server, basically as a NAS. And so what I'm going to be able to do is I'm actually going to be able to connect to it by typing SMB. We're not going to use this, but that IP address, 10.20.1.1. And so it's successfully said, hey, we found it. And now I'm going to go ahead and type in Pi, which is the username I set up with SMB, and sign in. And just like that, we were able to mount it. And so let's go ahead and do a Blackmagic speed test to see how fast this Wi-Fi connection can be. We're definitely not going to be saturating the drive because it's an SSD and it's over Wi-Fi, but it is over 5 gigahertz, which should be pretty quick. Oh, whoops, I mounted the wrong shared folder real quick. Sorry about that. That was the wrong shared folder. So it is not great. It's pretty slow. To be fair, it's probably also not getting as much power as it would like, but it is usable. We're able to write over the Wi-Fi network for text files and collaboration and stuff like that. This is going to be totally usable. Another thing is I definitely could do better if I had a bigger power supply, I think. Right now I'm just running off of my computer's USB power supply, but if I gave it the full power it needed, it would probably be going faster. Plus, I don't even have the Ethernet cable plugged into it right now. So honestly, it's a great mobile setup for anything you need. And if you'd like to know how I set up this Raspberry Pi Samba server, I've got a tutorial and I'll leave that in the description below. Alright, well now we're set up. Our Raspberry Pi is now creating a 5 GHz Wi-Fi network that we're able to connect to, and if there's an Ethernet cable plugged into it with internet, it'll just go ahead and connect to that. It's a really easy setup and great for road trips or anything like that where you need a really mobile setup for Wi-Fi. Alright, well that's going to be it for this tutorial. Go ahead and leave any other tutorials you'd like to see me make in the comments below, and have a good one. Bye!